Yes, fine. Yesterday, we discussed up to velocity and acceleration.
Yes, sir.
Today, we'll discuss about uniform motion, non-uniform motion, non-uniform motion, and thereafter, average speed, average speed, average velocity, average velocity, and then instantaneous velocity. Okay. These are the topics we'll discuss today.
Okay, sir.
Okay, na? Fine.
Okay, sir.
Okay, fine. Now, you can see, firstly, suppose I'm having a particle of mass m. Okay. Let us consider particle is moving. Particle is moving along a straight line. Okay. That's what in this chapter. Either parallel to x-axis or parallel to y-axis or parallel to z-axis. It is moving. Okay. Then, whenever it is moving, okay, we need to explain the motion. That is, uniform motion means that the object or particle, okay, the object travels equal distances in equal intervals of time. Equal distances in equal intervals of time. Okay.
Okay, sir.
In equal intervals of time. That means mathematically we can write as S is directly proportional to T. S is directly proportional to T. Okay. As time increases, okay, distance also increases. Okay, na?
Okay, sir.
Okay, fine. Suppose as time decreases, distance will also be decreases. And distance will also be decreases. Okay, fine. So here we can say that, okay, in order to remove this proportionality, we are keeping a constant. Suppose S equal to constant into T. Constant multiplied by T. Okay, fine, right now.
Complete.
Okay, na? So S means a distance. Distance by time equal to constant. Right?
Yes, sir.
Fine. S by T equal to constant. Distance by time means nothing but speed. Nothing but speed. That means S is proportional to T means, say for example, let us consider we are having a set of values. Suppose this is S, this is T. Okay. For a time, 1 second. Okay. Distance travel is 2 meters. Time increased by two times. So distance will also be increased by 2 times. Okay. Suppose time is increased by 3 times with the initial value. So distance also increased by 3 times the initial value. Like that. Okay, na?
Okay, sir.
Fine.
Yes, sir.
Like that. Suppose as time increases, distance will also be increases. Okay, na?
Okay, sir.
Fine, na?
Yes, sir.
Okay. So first point it is that, okay, S is equal to some constant into T. And this constant has the speed that I am writing as C. Okay. So second one it is speed will be constant. Can I say?
Yes, sir.
Okay. Now see, if I draw the graph on x-axis it is time and on y-axis it is distance. It is distance. Since we are having S equal to CT, instead of on y-axis we are having S. Instead of x-axis we are having time. Okay. T it is a constant. So it is just like it is in the form of y equal to mx. Y equal to mx. Y equal to mx means the graph will have the shape like straight line passing through origin with positive slope. Okay, na?
Okay,
So
sir.
motion of object is straight line passing through origin with positive slope. Fine. Next, as speed is constant, we can say that acceleration will be zero. Acceleration will be zero.
Yeah.
Okay, na? Since it is moving in a straight line, okay, distance equal to displacement.
Yes, sir.
Distance equal to displacement. That is speed equal to velocity. As distance equal to displacement means, can I say that speed equal to velocity? Okay, na?
Okay, sir.
Fine. Okay, fine. Okay, next. These are the 5 points you need to remember in uniform motion. Once you see, distance equal to speed into time or constant into t. Constant into t. And speed is constant. Speed is constant. Okay, fine. Next. Motion of object is straight line passing through origin with positive slope. Okay, na?
Okay, sir.
Fine. Na? Okay. Next. Acceleration as the speed is constant. Speed equal to velocity equal to constant. So acceleration will be 0. D by dt of constant means 0. Okay, na?
Okay, sir.
Fine. Next. Next one, it is non-uniform motion. Non-uniform motion. Okay, na? That means if the object travels, unequal distances, either in equal intervals of time, or unequal intervals of time. Okay. If you see before, you can see here, I have taken the equal interval for every period or interval. It is 1 second, right? This we can call interval.
Yes, sir.
So that is the equal interval. That is the
Equal interval.
okay. Now here it is either equal intervals of time or unequal intervals of time.
Unequal intervals of
Unequal intervals of time. So that means S is proportional to some t power n, where n belongs to set of rational number. Okay. For example, I am considering S is proportional to t square. Okay. S is proportional to t square. Okay. That means suppose initially t1 equal to 1 second, s1 equal to s. Time is increased by 2 times. I'll find s2. Okay. Fine. So, can I say that S1 by S2 equal to T1 by T2 whole square? Can I say? Is it fine?
Yes, sir.
Okay. So, S1 means S by S2 equal to 1 by 2 whole square. That is S2 equal to 4S. That means as time is increased by 2 times, distance is increased by 4 times. Okay.
Yes, sir.
Suppose if time equal to 3 seconds, that is time is increased by 3 times. Distance will be 9s, right?
Yes, sir.
4s and 9s depends upon the t square, na?
Yes, sir.
Right? Depends upon the given equation. If they gave t cube or t power half, then it will be decreases. As time increases, distance increases according
Okay,
to
sir.
the equation. According to the equation. Okay, fine. According to the equation. So in this case, I can say that in this case, I can say that number one, it is distance is not equal to displacement. Distance is not equal to displacement. And as a distance is not equal to displacement, we can say that speed is not equal to velocity. Okay, now?
Okay,
And
sir.
it is not constant. It is variable. It is varying. Okay. It is varying. So acceleration is non-zero. Suppose, for example, let us consider S is equal to t power half. T power half. Then velocity means ds by dt. Okay, na? That is d by dt of t power half. D by dt of t power half. Half into, if we differentiate it, we'll get as half minus 1 means we'll get minus half. Okay, na? So velocity equal to 1 by 2 into t power minus half. So acceleration will be half into d by dt of t power minus half. Right?
Yes, sir.
So that's why we can say that acceleration is non-zero in non-uniform motion.
Okay, sir.
Motion of an object will be random. That means depends upon the case of n value. This n value will have the distance. With respect to that, we'll find the, with respect to that, we'll find the shape. Suppose s equal to t square, then we'll have the shape like this.
Para.
Like parabola. Oh, Okay, na? That
Okay,
depends upon the n value. Okay, na?
okay, sir.
Fine. Na?
Yes, sir.
Fine. Okay. Motion of object and this one. Okay. I think almost all points we discussed. Na? Okay, na? This one.
Okay.
This page completed. Huh?
Yes, sir.
Okay, fine. Next, this page
Completed, sir.
completed.
Yes,
Okay.
sir.
This is what random motion. Suppose, for example, I'm saying, if a person is climbing up a mountain and coming down, and again, like this, okay? While moving up, velocity will be decreases. While moving down, velocity will be increases. Okay? While
Yes,
climbing up, while climbing up, velocity decreases. Velocity decreases. Because as height increases, velocity will be decreases. Okay. While coming down, velocity increases. Okay. Because as height decreases, velocity increases. Okay, na? Fine.
okay, sir.
Okay, fine. Now, based on this, we need to find average speed and average velocity. Average speed, comma, average velocity. Average velocity. First, say for example, let us consider we are having an object of mass m, which starts from the point O. Okay. And it is moving to a point. Suppose this is A. At B, we are having a velocity V1. At C, we are having a velocity V2. Before reaching A, we are having a velocity V3. Now I want to find what is the average velocity from initial point to the final point. Okay. From initial point to the final point, we need to find what is the average speed. Since it is moving in a straight line, I can say that distance equal to displacement.
Yes, sir.
So speed equal to velocity. Generally, average value, average, or we can also say mean value. Average value means number of observations, sum of all the observations by number of observations. Okay. Suppose, for example, okay, I am having the 5 watches are there, either wall clock or wristwatch. Either wall clock or wristwatch. Okay, I'm having. So in each watch or clock will have the different time. Right? At least they may differ by minutes, or they may differ by seconds,
Yes, sir.
right? Suppose the reading in each watch I'm indicating with X. I'm indicating with X. So suppose if I'm having 5 readings, so sum of all the 5 readings, by number of readings or number of observation can be called as average value. Okay. Suppose you can see, I think in 10th class, you might have the 6 subjects, right?
Yes, sir.
6 subjects. The total marks it is 600. Okay. You
Yes, sir.
got the in each subject mark. Now I want to find what is your average mark in each subject. So I will add these 6 subjects marks by number of subjects, that is 6. Right?
Yes, sir.
So in some subject, maybe your marks will be greater than your average mark. In some subjects, maybe less than. Okay.
Okay, sir.
Okay, fine. Similarly, here I need to find average speed. Average speed. This average speed I will indicate with speed we indicate with C. So I kept the C average. Okay, C average. Generally, speed means distance by time. So it is total distance by total time. Okay, na? Fine. Na? Total distance means from O to A. Time taken from O to A. Right? Okay, na? Is it fine?
Okay, sir.
Okay. Now, this OA, I am dividing into 3 intervals as OB is one interval. That is first interval. And B to C, it is my second interval. And then C to A, it is third interval. Third interval. Okay. So this we are writing it as OB plus BC plus CA. Time taken from O to B, it is T1. Time taken from B to C is T2. And time taken from C to A is T3. Similarly, distances S1, S2, S3. Okay, na? Fine.
Yes, sir. Fine.
So, average speed it is, average speed, total distance, that means C average equal to S1 plus S2 plus S3 divided by T1 plus T2 plus T3. Right? Okay, na?
Okay, sir.
Fine. Okay. So, average speed, we are having the formula. If we are having the 2 intervals, we can write up to S1 plus S2 only. Okay. Since in the first interval, distance traveled is S1, time taken is T1. So, can I say that speed V1 equal to S1 by T1?
Yes, sir.
Because speed equal to velocity. And can instead of C1, I'm writing it as V1. Similarly,
sir.
similarly, V2 equal to S2 by T2 and V3 equal to S3 by T3. Same in this equation, if they give velocity and time, if velocity and time are known in each interval, are known in each interval, then S1 can be replaced as V1 T1. Can I write? Okay, na? Is it fine?
Yes, sir.
Okay, fine. So if they give velocity and time, I'll use this formula. If they give distance and time, I'll use this formula. Okay.
Okay, sir.
Suppose if distance and time are known, sorry, distance and velocity, there are known in each interval, then we'll replace the time. We'll replace the time, that is T average equal to S1 plus S2 plus S3 divided by time. How can I replace? Time. How can I replace?
T1, T2.
Hmm?
T1, T2.
T1 I can write as S1 by V1. See? Okay, na?
Okay.
Fine. Plus S2 by V2 plus S3 by V3. Okay. That depends. If the distance and time they gave asked to find average speed, then I'll consider first equation, first formula. If they give velocity and time in each interval and asked to find average speed, then I'll consider second formula. Okay.
Okay.
Fine.
Yes, sir.
Okay. In uniform motion, in uniform motion, speed equal to velocity, right? And distance equal to displacement. Distance equal to displacement. So I can say that average speed equal to average velocity. Okay, na?
Okay, sir.
Average speed equal to average velocity. So in uniform motion, both will be the same. Both will be the same. Okay. Next, in non-uniform motion, in non-uniform motion, okay, distance is not equal to displacement. Distance is not equal to displacement, and speed is not equal to velocity.
Yes, sir.
Speed is not equal to velocity.
Not
Right.
equal.
Fine.
Yes, sir.
So average speed is not equal to average velocity. Both are different in this case. Both are different in this case. Okay, fine. First, let us consider a particle starts from A, moves to B, and then C, and C to D. It travel from A to B, travel a distance S1 in a time T1. And B to C, travel a distance S2 in a time T2. And then C to D, travel a distance S3 in a time T3. Okay?
Okay, sir.
Okay, fine. So, average speed means S1 plus S2 plus S3 divided by T1 plus T2 plus T3. Right?
Yes, sir.
So, average speed, it is S1 plus S2 plus S3
S3.
divided by T1 plus T2 plus T3. Okay. Now, average velocity. Average velocity. Okay. From A to D, it is displacement I want. Okay. What I will do that in order to find displacement, okay, A to C plus C to D. Okay, na? A to C plus C to D. Right?
Yes, sir.
Okay. Let us consider this displacement as R21. So the total displacement means R21
Yes, sir.
plus S3 by, okay, time taken from A to D. Okay, na? This page completed, huh? See,
No, sir. Have to write.
right down. Okay, na? Completed.
Yes, sir. Completed.
Okay, fine. Okay, na? Fine, na?
Yes, sir. Completed.
Completed?
Yes, sir. Completed.
Completed. Next, write down one example based on this average speed and average velocity. Okay. Based on this average speed and average velocity. Example it is a man who walks 720 meter at a uniform speed of 2 meter per second. 2 meter per second. Then runs at a uniform speed of 4 meter per second for 5 minutes. 5 minutes. And then again walks at a speed of 1 meter per second for 3 minutes. Find his average speed. Find his average speed. Okay, na?
Okay, sir.
Fine. First see, a man who walks 720 meter. That means S1 equal to 720 meter and V1 equal to 2 meter per second. Okay. So time taken, I can say 360 seconds. Right? And then runs at a uniform speed, V2 equal to 4 meter per second for a time. 5 minutes means convert into seconds. That is 300 seconds. Okay, na? Ante
Yes, sir.
S2 equal to 1200 meter.
Yes, sir.
Next, and then again V3 it is 1 meter per second for a time of 3 minutes. 3 minutes means 180
186.
seconds. Ante S3 equal to 180 meter. So average speed, you can use any formula. I am using the total distance by total time. Here, you know S1, V1, T1. You can use any formula. Okay, na? Fine.
Okay, sir.
Okay. So, upon this one, we'll get average speed equal to 720 plus 1200 plus 180 divided by first T1 360. Next T2 300, T3 is 180. So upon calculation, we'll get numerator, I'll get as 900 plus 1200 by 540 plus 300. So it is 2100 by 840. Right?
Yes, sir.
అంటే ఇది 4 times. Okay, 100 by 40, that is 25 by 10. So C average equal to, okay, C average is equal to 2.5 meter per second, right?
Yes, sir.
Fine.
Thanks, sir.
Is it okay?
Okay, sir.
No, fine. This page completed.
Eh,
This page over. Okay. Next question. See the example 2. A particle starting from point A, traveling up to B, with a speed S. Be careful. Here they gave the speed as S. Then up to point C. Up to point C. With a speed 2S. And finally up to A with a speed 3S. Then find its average speed. Then find its average speed. Okay. Draw the diagram. This is the center O. This point is A. This point is B. And here it is C. Okay. Okay, na? Fine.
Okay, sir.
Hmm. Draw the diagram.
Okay, sir.
Okay, na?
Done, sir.
Hmm. Now, firstly, particle moves from starting from A and moves up to B, right? A
Yes,
to
sir.
B. Okay. So let us consider distance traveled in AB. Okay. This total distance it is 2 pi r. Okay.
Okay, sir.
Okay. Suppose total distance equal to distance of AB plus distance of BC plus distance of CA. That is equal to 2 pi r. Okay, na?
Okay, sir.
Okay. Now, this OAB, it is in the form of arc, right? Suppose If we are having arc, the
yes,
length of the arc, Ona,
yes, sir.
we know that length is nothing but equal to the distance only.
Yes, sir.
Okay. So length of arc equal to r theta. Similarly, distance of AB, can I say that r into theta means angle pi by 2? Similarly, distance of BC, r into 2 pi by 3. Okay, na?
Okay, sir.
So now I want to know this angle. Okay. 2 pi by 3 means convert into degrees. Convert into degrees. How much it is? 2 by 3 into pi radians means 180 degrees.
120.
Okay. That is 120.
Yes, sir. 120.
Pi by 2 means 90 degrees.
Mm.
120 plus 90. 210. Na?
Yes, sir.
Total it is 360.
360. Yes, sir.
360
360.
minus 210.
150.
150 degrees.
Yes, sir.
So 150 degrees, okay, into convert into radian, that is pi by 180. So it is 5 pi by 6. Okay, na? Is it fine?
Yes, sir.
Distance of CA it is 5 pi by 6. So I will add all this here. That means R into pi by 2 plus R into 2 pi by 3 plus R times 5 pi by 6 is equal to 2 pi R, right? Just I substitute values. Distance of AB, BC and CA. Okay. Fine. So pi R I'm taking common. Okay, na? Fine. Otherwise, 1 minute. Although instead of this one, let us consider I need to find the average speed. Na? Here
Yes,
it
sir.
is time T1, this is T2, this is T3. Here speed is S, and then B to C it is 2S, and then here it is 3S.
Yes.
So T1 equal to distance of AB by speed. Distance of AB means R into pi by 2 by S. That is R pi R by 2S. Similarly, distance of BC by its speed, that is 2S. Distance of BC it is R into 2 pi by 3 by 2S. So R into 2 pi by 3 into 2S. So to cancel, so pi R by 3S. And T3, distance of CA by 3S. Speed of CA is 3S. Right? Fine. So R into 5 pi by 6 by 3S. So it is 5 pi r by 18s. So C average equal to total distance of AB plus distance of BC plus distance of CA by time taken T1 plus T2 plus T3. Total distance means nothing but 2 pi r. Okay, na? Fine, na?
Yes, sir.
Okay. Total time. Substitute the value of time. What is the value of T1?
5
Pi r by 2s.
air between.
Okay. Pi r by 2s plus pi r by 3s plus 5 pi r by 18s.
18s.
Okay. So C average equal to 2 pi r. I'll write as pi r into 2. In the denominator, pi r by s I can take common.
Yes, sir.
1 by 2 plus 1 by 3 plus
Plus
5 by 18. So pi r cancel. So average speed equal to
2 by
2 by 1 by s times, I think 1 by 2 plus 1 by 3 plus 5 by 18. Take LCM. What is the LCM? That is 2s by 18. 9 plus 6 plus 5. So it is 36s by 20 later. So it is C average equal to 1.8s. Is it fine?
yes, sir.
Okay, na? Okay, fine. This page completed, huh?
No, sir.
Right on.
Finished, sir. Sir, completed, sir.
Okay, na? Over?
Yes, sir. Completed.
Okay, fine. Okay, na? Over. Okay, na? Completed.
Sir, completed, sir.
Completed. Okay, fine. Next.
Yes, sir, completed.
Completed.
Yes, sir.
Okay. Next one, before going the instantaneous velocity, okay, we are having the applications of average speed. Applications of applications of average speed. Okay. These two applications are most important. These two applications are most important. First application it is if the particle travels equal distances, equal distances in two intervals of the entire journey. Two intervals of entire journey. Then its average speed is. Then its average speed is. Okay, na? Then its average speed we need to find. Okay, fine. Suppose
Okay.
let us consider particle starts from O and reaches to A. This is the total distance traveled. Total distance traveled. Okay. Suppose O to B is S by 2 and B to A is S by 2. Okay. Fine.
Yes, sir.
Here O to B moves with a speed V1 and V2. Correspondingly, time it is T1 and T2. So, average speed I can write as, here I know distance and velocity, right? So, S1 plus S2 by T1 plus T2. T1 I don't know. So, I am replacing the time as distance by speed, right?
Yes, sir.
And S1 means S by 2 plus S2 also S by 2. Okay. This is S by 2V1 plus S by 2V2. That means average speed equal to numerator will be S. Denominator, take S by 2 common. 1 by V1 plus 1 by V2. Okay. Denominator, take LCM. That is V1 plus V2 by V1 V2. That is 2V1 V2 by V1 plus V2. Right?
Yes, sir.
Fine.
Yes, sir.
Is it okay?
Sir,
Uh,
మీ
very good.
వాయిస్ మధ్యలో స్ట్రక్ అయింది సార్.
See here, S by 2 plus S by 2 divided by S by 2V1 plus S by 2V2.
ఎస్ సార్.
S1 means S by 2 కదా.
ఎస్ సార్.
అవునా? అంటే numerator value will be S. Denominator take S by 2 common,
ఎస్ సార్.
which will get 2V1 V2 by V1 plus V2.
ఎస్ సార్.
That is the first application. This formula to be used when it travels equal distances. You can underline this one.
ఈక్వల్ డిస్టెన్స్. ఓకే సార్.
In each interval, we are having the equal distance. Now, see, S by 2.
ఎస్ సార్.
Okay. Fine. Second application, similar to the first. Now, if the particle travels distances, distance S1 with a speed U and distance S2 with a speed V, in equal intervals of time. Then its average speed is, okay, fine.
ఓకే సార్.
That means same as like before, particle starts from O and reaches to point A. O to B takes a time T1 and B to A takes a time T2, such that T1 equal to T2 equal to T by 2. Okay, in equal intervals of time. O to B travel a distance S1 with a speed, V, with a speed U. B to A with a speed V. Right? Fine.
ఎస్ సార్.
So, average speed means S1 plus S2 by T1 plus T2. Here I know T1 and T2. So, I am replacing this S1 as V1 T1 plus V2 T2. Right? So C average equal to U into T1 means T by 2. V2 means V. T2 is also T by 2. Right? Okay, na? Fine.
Okay, sir.
Okay. So average speed, take T by 2 common, V plus U. T by 2 plus T by 2 means nothing but T. So here average speed means V plus U by 2. Okay, na? Is it
Okay,
fine?
sir. Yes, sir.
So here you need to observe that whenever particle travels in equal intervals of time, then we'll use this formula. Equal distance means 2v1 v2 by v1 plus v2. Okay,
Okay, sir.
fine. Na? Is it okay?
Yes, sir. Okay.
Okay, fine. Na? Suppose here I'm having two intervals. If I take three intervals, then average speed will differ. Right? Na?
Yes, sir.
Because instead of s by 2, we'll have s by 3. Right? Na?
Yes, sir. Three intervals.
Instead of s by 2, we'll have s by 3.
Yes, sir.
Right? Now.
Completed, sir.
Fine. Na?
Yes, sir.
Uh, Okay, na? Completed.
Yes, sir.
Next. Next one it is instantaneous velocity. Instantaneous velocity. Okay. Now let us consider particle starts from O and reaches to point A. It takes a time 10 seconds. Okay. 10 seconds. Before reaching A, here I'm having 20 meter per second. Okay. Soon after starting, it is having an initial velocity as 1 meter per second. 1 meter per second. Okay. Fine.
Okay, sir.
Okay. Now, I want to find what is the velocity in between at any point. Okay. Either at 3 seconds or 5 seconds or 9 seconds. Okay. Instantaneous velocity means velocity of an object. Velocity of an object at a particular time, at a particular time can be called as instantaneous velocity. Okay.
Okay, sir.
During this path, okay, the displacement is varying with respect to time.
Yeah, yes, sir.
S is varying with respect to time, right?
Yes, sir.
So they will give an equation, a simple equation I'm taking. Okay. T cube minus 2t square plus 10t minus 20. Like this, they will give the equation. We need to find instantaneous velocity at t equal to 2 seconds. Okay, na? Fine.
Okay, sir. Right.
Okay, fine. So generally velocity means I can say rate of change of displacement.
Yes, sir.
Here, particle moving in a straight line. So distance equal to displacement. Distance equal to displacement. Okay. So that is ds by dt. First, we'll differentiate it.
Different.
That is d by dt of t cube minus 2t square plus 10t minus 20. Okay, na?
Okay, sir.
Okay. Now do the differentiation. How to do the differentiation?
Individual.
That is apply differentiation separately minus d by dt of 2t square plus d by dt of 10t. Okay. 10t minus d by dt of 20. Okay. D by dt of t cube means 3t square, na?
Yes, sir.
Right?
Yes, sir.
So instantaneous velocity will be 3t square minus constant, bring it outside. D by dt of t square means 2t. So it is 2 into 2t. Next, here constant is 10. D by dt of t means 1.
Yes, sir.
Okay. Plus 10 into 1. D by dt of 20. That is constant.
20.
That is 0.
Yes, sir. It is fine.
So instantaneous velocity is 3t square minus 4t plus 10. They asked to find at a time 2 seconds now.
Yes, sir.
So V instantaneous equal to 3 into 2 square minus 4 into 2 plus 10. That is 22 minus 8, 14.
Yes, sir. 40.
Okay. Like this, we'll find the instantaneous velocity. Okay.
Okay.
That is instantaneous velocity means velocity of an object at a particular instant of time.
Travel.
Not only time and position also. Sometimes they will give position also
Okay, sir.
at a particular, because velocity is a function of time and position right now.
Yes, sir.
As position differs, velocity will differs. And as time differs, velocity will changes.
Sir.
Okay, na?
Okay, sir.
Fine, na?
Fine, sir.
Okay. Up to here, remember, okay? In the tomorrow class, some more problems on this instantaneous velocity will do. And thereafter, mostly in another equations of motion, motional gravity, and graphs. Next two classes in another tomorrow and another one more class. We will finish the synopsis, this chapter.
Okay, sir.
Mostly in another three classes, we'll finish this chapter. Okay, na?
Okay, sir.
Fine.
Right, sir.
Thereafter, we'll do problems. Okay, ma. Tomorrow we'll meet. Same time, ma. 11 o'clock only.
Okay, sir.
Tomorrow Saturday, na?
Yes.
Same time.